Bismillahirrahmanirrahim. Dear viewers, now I am going to show the load application on floors in RAM structural system. This is the third tutorial on RAM structural system. So let's start. We will go to see here. Next, get loads. Go to property table, then loads surface. Name it as floor load. So we'll go to property table, load surface. Here are the option for line load also. Surface floor floor load dead load. I will apply the floor finish 25 psf construction load. This is the load. See here, construction load means the self weight of the slab or wet concrete. So the load while pouring concrete, that time wet concrete having self weight but cannot take the load by the slab itself. That loads are taken by shutter supports and columns. So we will put this load 7-inch thickness. 7 by 12 means this feet, to convert into feet, and 150 pcf pound per cubic feet unit weight equal to 87.5 psf load for 7-inch slab. So we will put construction dead load 87.5, live load 42 psf for residential use purpose. Now live load reducible, yes. For roof load we will click on the roof, then it will be calculated as per the roof equation. Partition load, see here, we will use partition load. Partition wall load considered 10 to 15 psf uniform on floor, as we don't consider the walls are fixed in the building for whole life of the building. Walls can be broken and constructed to different location according to the floor layout changes. Construction live load 25 psf. Partition wall load 15 psf. I will provide construction live load 25. During the construction 25 psf load are working in the floor. Mass dead load, it is I will take only floor finish load 25 psf, and other self weight will be calculated by the story message by the program. So now if we add this load, then it will ask for the construction dead load should be a portion of this total dead load. Check add construction load must be entered as portion of dead load. So what we can do, this is not a major factor in concrete structure, this is major in steel structure, because the construction load will be carried by the decking system, but for concrete structure it will be carried by the temporary shuttering supports. So it is not much important in concrete construction. So that's, if we want to consider this load, then we have to add the slab self weight here 25 plus 7 inch slab thickness self weight. In that case we have to unmark this slab and this option from our criteria. For example, I will give 20 psf load to be considered as construction load during the construction. If you want to provide the full load, you have to add the slab self weight and you have to unmark this two option. I repeated this to be careful. Now I will add this one. Okay, done. Now I will go to load, line load. I will write it as wall load. Here you see the seismic the mass dead load is for seismic effect, and we will just take the floor finish load as other self work will be calculated by the program. It's okay. Then apply line load considering peripheral walls are permanent for whole life of the building. So here this is keep per feet. If it is 10 feet height and the 5-inch brick wall, then 10, that means 500 pound per feet per linear feet, that means 0.5 kg per feet. With this I will not take no live load, unreducible. You can choose this one. Partition, this no need. Construction live load, no need. Mass dead load, you can take it as 0.5. Okay, then add. Okay, now we will apply the loads. Go to load, surface load, select the whole floor also will be selected as it is the floor defined by the edges. We'll use this one. So the load has been applied, and now I can apply the line load. This one, whole perimeter we can apply. We can apply in the whole diagram. We can add on beam. This I will select. This, and this. We will select the beams. These are shear all, so no need. Done. Okay. So wall load, line load and floor load we have applied. Now we will create ground, floor and then roof. In the ground floor I will use grade beam. So go to type, select this one. I will add grade beam, then add, select. Okay, now not history, go to type, then copy from typical wall. I will select this beam, column, wall, and this taking and load I will not bring because it is grade beam. Okay, here I can apply the load, wall load, layout load, line load. I can apply this line load, this add-on beam. Here inside the building, if there is line load, okay. So in this way we can apply the loads on grade beam. So this is our grade beam. Now we will go to layout, type, select. We will add roof, add, select. We will go to layout, type, copy. Now in this case we will copy all from typical. Done. Here we will we'll go to layout, load, surface load. We will change. Okay, first we will define another load, roof, load. Okay, this roof and other 25 floor finish, this 20 as I have taken. Live load we can take 50 if there is any party on the roof, so 50 or 60 we can take this. Partition load, here we will consider no partition will be provided, we will keep it 0. Live load 25, mass dead load I will provide 25, then add. Okay, now I will change this one to roof. Okay, and the line load I will add another. We use parapet load. This is normally 4 feet, so for it will come like 0.2 kip per feet. Construction I will not take. This is live load unreducible. Partition no need. Live load no need. Mass dead load 0.2. Okay, add. Okay, now I will go to load, line load, then change this to this, and we can do another thing. Load, line load, delete fence. Okay, done. Now I will apply the parapet load, add on beam, done. We will save the model. Now our grade beam, typical floor and roof has been created. If there is first floor height is different, we can create a first floor also. We will go to type, select, then we will create first floor, add, select, then we can go to type, copy from typical all. Okay, done. Now we will define history. Let's see. Go to history, then this is grade beam. This is level number 1. Splice level, that means if I want to change the column size, then we can click on yes, otherwise we will click no. Add, this is floor height. We will provide 6 feet from the foundation. Add, then first this one, add, this floor will be 12 feet height, change this 12 feet height. Then number 3, second, we will select typical. No, this height will be 11 feet, add, and 4 will be third, same typical, add, fourth typical, add, 5, add, 6, add, 7, add, 8, add, and 9th one we will select roof, add. Okay, now our modeling has been finished. We can check the modeling data. Okay, so no error or warning found in RCC building design, the name of the model. Close. We can check the frame only also. Is now assigned is the grade beam. We will check this one. So as it is so as it is showing the warning, we will go to from grade beam. We will assign the column assign size, fence, this, for making it short I am selecting all to save the time. Okay, then go to first layout, column, assign size, this one, fence, I'll select one. Okay, go to roof, then I will assign size, fence. Okay, and typical also go to layout, assign size, select this fence and this. Okay, now we can check this data. So no error and warning found in the RCC building. So in this way we can check our modeling and we can fix the issue. Now we will get a 3D view here. So this is our 3D model. Press shift and left side of the mouse to move this, or no need to press shift, just left side of the mouse can move this one in this way, and press Ctrl to rotate. Press Ctrl and left side of the mouse to rotate the building and to explore it carefully. In the roof, if we want to close the opening, we can do it. We will go to the roof, close this one, roof. Now layout, slab, opening, delete this side. Okay, done. Now we can check again. See, shift left side of the mouse, then rotate it. See, this opening has been deleted. So this is our 3D model, and now we will add foundation. We will go to grade beam. Okay, here we will add foundation single column. Okay, split foundation. If it is not passing in split foundation according to the soil report, then we can provide pile cap. Okay, so in this tutorial I am going for split footing, concrete strength for footing 3. I will keep same. Self weight, this is okay, normal. Okay, elastic modulus and reinforcement. Okay, a single, or we can use fence. This see the foundation direction aligned with the column direction automatically. This, 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 and this one, this one. Okay, here we will provide the layout foundation, continuous foundation. Okay, this all are same. I will keep same, and the distance from center line within the walls to be included. We have to provide the full width, both side, total width like 24 inch. Add here to here, here to here, here to here. Okay, so our another balance continuous add here to here, and here we will delete the split footing foundation, delete fence, this two because here is shallow, and provide continuous add 24. Okay, so we have provided our foundations, and these foundations also will be designed and checked by the software. Now we can see the 3D view. See, this is our 3D model with foundation in RAM structural system. Okay, now we will save the model. Done. This is roof, typical floor. Okay, so in this way we can create a model in RAM structural system for RCC building.
Press the bell icon on the YouTube app and never miss another update.